Now let us solve a problem based on heating of electrical machines. A field coil has a heat dissipating surface of 0.15 meter square and a length of mean turn of 1 meter. It dissipates a heat of 150 watt. The emissivity being 34 watt per meter square degree Celsius. Estimate the final steady temperature rise of the coil and its time constant if the cross section of the coil is 100 by 50 mm square. Specific heat of copper is 390 joule per kilogram degree Celsius. Space factor is 0.56. The weight of copper is 8900 kilogram per meter cube. So these are the parameters given. So first of all, while watching this video, please note down all the parameters first and then try to do it along with me. Okay, so let us note down the parameters given. So first, all these informations are regarding a field coil. An entire machine alla, ഒരു മെഷീന്റെ ഫീൽഡ് കോയിൽ മാത്രം കൺസിഡർ ചെയ്തിട്ട് അതിന്റെ ഹീറ്റിങ്ങിനെ കുറിച്ചാണ് പറയുന്നത്. So first of all, the coil is having a heat dissipating surface of 0.15 meter square. So the dissipating surface area is 0.15. So how will you denote that parameter? Dissipating surface area S is equal to 0.15 meter square. And it is having a length of mean turn of 1 meter. The length of that coil is 1 meter. Okay. Average length of that coil is 1 meter. So let it be denoted as L. It dissipates a heat of 150 watt. The heat dissipated is 150 watt. Heat dissipated is given in watts. That means it is the power loss Q. So Q is equal to 150 watts. മനസ്സിലായോ? പവർ ഹീറ്റ് ഡിസിപ്പേറ്റ് ചെയ്യുന്ന എന്തുകൊണ്ടാണ്? പവർ ലോസ് ഉണ്ടാകുന്നത് കൊണ്ടാണ്. സോ ഈ വാട്ടിൽ തന്നിരിക്കുന്ന ആ പാരാമീറ്റർ എന്തായിരിക്കും? ഇറ്റ് വിൽ ബി ദ പവർ ലോസ് ഓഫ് ദ മെഷീൻ. സോ നൗ ദ എമിസിവിറ്റി ബീയിങ് 34 watt per meter square degree Celsius. What is emissivity? Same as heat dissipation, emission, emissivity. So it is 34 watt per meter square degree Celsius. That is lambda. Lambda is equal to 34 watt per meter square degree Celsius. So we have to calculate the final steady temperature rise. That is theta m we have to calculate. And its time constant. So this machine is being heated. So time constant means heating time constant TH. If the cross section of the coil is 100 by 50 mm square. So cross sectional area of the coil. Coil in the cross sectional area aanu. It is not the dissipating surface area. S alla. S is the dissipating surface area which is already given as 0.15 meter square. So the cross sectional area of the coil is how much? 100 by 50 mm square. So A cross sectional area is 100 by 50 mm square. Specific heat of copper is 390 joule per kilogram degree Celsius. So H is given as 390 joule per kilogram degree Celsius. Space factor is 0.56. Let us denote it as K. Space factor for copper is 0.56. And copper weighs about 8900 kilogram per meter cube. Weight of copper is equal to 8900 kilogram per meter cube. So we have to calculate the final steady state temperature theta m and the heating time constant Th. So let us substitute the equations for these parameters. So what is the equation for theta m? Theta m is equal to Q divided by S lambda. So Q divided by S into lambda. So Q is given as 150 watts. Then S, dissipating surface area, is 0.15 meter square, and lambda, the specific heat dissipation or the emissivity, is 34. So substituting all the values, we will get 150 divided by 0.15 into 34, and the answer will be 29.4 degrees Celsius. So this is the answer for theta m. We can directly substitute the given values and calculate theta m. So now we have to calculate the heating time constant Th. So what is the equation for Th? It is Gh divided by S lambda. So H is the specific heat of the machine, which is given, S given here, and lambda is also given. So what is G? G is the weight of active parts of the machine in kilogram. But here the weight of copper is given in kilogram per meter cube. That is, the weight per unit volume is given, kilogram per meter cube. So we have to convert this into kilograms. So for that, we have to substitute the weight by the volume of the coil. We have to substitute weight in kilogram per meter cube by volume of the coil in meter cube. Then we will get weight G in kilogram. So let us calculate the weight of the coil. Okay. So we'll get the weight of the coil. It is given in kilogram per meter cube. So in order to get the weight in kilogram, we have to multiply this by the volume of the coil. So let us calculate the volume. Equal to, so volume of the coil. See, length of the coil is given as 1 meter. Then the cross-sectional area of the coil is 100 by 50 mm square. So when multiplying the cross-sectional area of the coil with its length, we will get the volume of the coil. So length is 1 meter into area is 100 by 50 mm square. So we have to convert mm square into meter square. So multiply this by 10 raised to minus 6. So this will be the weight of the coil. But if we are considering a field coil, നമ്മളൊരു ഫീൽഡ് കോയിൽ കൺസിഡർ ചെയ്താൽ, ഏതെങ്കിലും ഒരു മെഷീന്റെ ഫീൽഡ് വൈൻഡിങ് കൺസിഡർ ചെയ്താൽ, the entire field winding, the weight of the entire winding will not be constituted by the copper. മൊത്തം വൈൻഡിങ്ങിൽ കോപ്പർ മാത്രമായിരിക്കത്തില്ല. There will be insulation over the winding. There will be insulation between different turns. അങ്ങനെ കുറെ ഇൻസുലേഷൻ ഒക്കെ കാണും. ഇൻസുലേഷന്റെ ഒക്കെ എല്ലാത്തിന്റെയും വെയിറ്റ് കൂടി ചേർന്നിട്ടാണ് നമുക്ക് ഈ വോളിയം കിട്ടുന്നത്. ഇൻസുലേഷൻ കൂടി ഇതിനകത്ത് വരുന്നുണ്ട്, അതും കൂടി ചേർന്നിട്ടാണ് ഈ വോളിയം കിട്ടുന്നത്. അതിൽ നിന്ന് കോപ്പറിന്റേത് മാത്രം കണ്ടുപിടിക്കാൻ വേണ്ടിയിട്ടാണ് എ സ്പേസ് ഫാക്ടർ ഇസ് ഗിവൺ ഹിയർ. സോ ഈ കിട്ടിയ എൻറ്റയർ വോളിയവും കോപ്പറിന്റേത് മാത്രമല്ല, ഇൻസുലേഷനും കൂടെ ചേർന്നിട്ടുള്ളതാണ്. സോ കോപ്പറിന്റെ ആക്ച്വൽ ആയിട്ടുള്ള വോളിയം എന്ന് പറഞ്ഞാൽ ഇതിനേക്കാളും കുറവായിരിക്കും. ഇത് ഇൻസുലേഷനും കൂടെ ചേർന്നിട്ടുള്ളതാണ്. സോ in order to get the actual volume of the coil, that is only the volume of copper, we have to multiply this value by the space factor. So into 0.56. So the answer will be 2.8 into 10 raised to minus 3 meter cube. So this will be the volume of the coil. So now on multiplying this by volume of the coil, we will get weight of the machine, weight of the coil in kilogram. So weight of the coil G will be equal to 8900 into this value, volume 2.8 into 10 raised to minus 3, and the answer is 24.92 kilogram. So this is the value of G. So now we will get TH as 24.92 into, what's the value of H? 390 divided by S lambda is 0.15 into 34. So answer will be, the heating time constant we will get it as 1906 seconds. So the answer will be in seconds.